Let's do 6.4 Part 2, Fundamental Theorem of Calculus, Part 2. All right, you already know that. We already know this. We've already worked with this. We're just going to formalize the name of it. If f is continuous at every point on AB, and if f of x is any antiderivative of f on AB, then when we evaluate this, we get the antiderivative evaluated at the upper bound minus the lower bound. And this computes a number, and it's the area under the curve. So, for example, if we were to go here, we would integrate this up, get an antiderivative of negative cosine of theta, and I still like to write pi over 4 to 3 pi over 4. Okay, and then we get negative cosine of 3 pi over 4, just popping in that upper bound, minus negative cosine of theta of pi over 4. Okay, I guess we don't really need these parentheses here, but anywho. Okay, so this is negative root 2 over 2. Okay, and this will just be positive root 2 over 2. So that's just root 2 over 2 plus root 2 over 2, which is 2 root 2 over 2, which is just root 2. Okay, and so that's using FTC number 2, which you've already been doing, and we just are formalizing it with the name. So if we graph this, we're going to graph the function. So we're graphing sine of x, and then this says what's the area under the curve from pi over 4 to 3 pi, and so we graph the sine of x from there to there, and this negative cosine is what will compute it, which is really kind of cool. All right, so this is pi over 4, and this is 3 pi over 4, and this is just like that. Okay, so that's 1. That's pi over, sine of pi over 2 is 1. So we get the sine curve down, so that just means this area under this curve is root 2. Okay, root 2. All right, root 2. Okay, so this answer here is a number, and it computes area between the curve, which is y sine of x, and the x-axis, always down to the x-axis. Okay, so this next piece here, we're going to just get this shaded region, and so we're going to have two areas to look at just by the nature of absolute value. Okay, so we need to remember our definition that in absolute value, it's a piecewise, and it's itself for x values, or 2x minus 1 values greater than or equal to 0, and it's its opposite for 2x minus 1 values less than 0. So that shakes out to be 2x minus 1 for x greater than or equal to 1/2, okay? And then negative 2x plus 1 for x values less than 1/2. So you can see that this line here is that negative 2x plus 1, which makes sense. Y equals, and this part here is y equals that 2x minus 1. So without using the TI, okay, so I would just use geometry here, even though we have calculus. If I see geometry, I'm going to use geometry. So area 1 is just going to be 1/2. 1/2 is that base, okay, and then the height there is just at 1, just that y-intercept right there. So this area 1 is 1/4. And then area 2 is 1/2, and this base is from 1/2 to all the way to 2, okay, all the way to 2, because that's where the shaded region starts. So that's 1.5, and then this has a height of 1, 2, 3. So this is 9 over 4, okay, and so area 1 plus area 2 is equal to 10 over 4. Which is 2 and 1, 2 and 1, well, 2 and 2/4, which is 2 and a half there. Okay, all right, and I mean, if we're doing area and thinking of it as a shaded region, we can put u squared, but you know, eventually we're going to be accumulating something here, or totaling something. If you were to check with your TI, you would just simply say the absolute value. Or the integral from 0 to 2 of the absolute value of 2x minus 1 dx. All right. I don't see my TI. Hold on, let me get it. Let me show that real quick and move on. All right, so you would just go math, not mode, math 9, math number, absolute, 2x minus 1, comma, x, comma, 0, comma, 2. All right, you get 2.5. All right, so there you go. And then you could also integrate it without a calculator by using integrals. You would just have to split your integral. And so they're both positive regions. So you could also do the integral from 0 to 1/2. And that would be this negative side. So you'd have to put in negative 2x plus 1 dx plus the integral from 1/2 to 2. And you'd have to put in this side, which is that 2x minus 1 dx. Okay? And this would certainly compute if you took that antiderivative up to negative x squared plus x and evaluated it from 0 to 1/2. Took this one up to x squared minus x, evaluated it from 1/2 to 2. You would certainly get 1/4 here, consistent with the triangle, and you would get 9/4 here, consistent with the triangle, for 10/4, consistent with the TI. So if you're not asked to do specifically calculus and you have triangles, why not use your geometry? All right, a couple of offshoots here. This one, the shaded area is not locked down to the x-axis. So two approaches here. A couple of things you can do if the shaded area is not kind of flush. I like to use the word flush with the x-axis. You could draw a rectangle and just do total minus part to get the shaded, like total minus unshaded. So area of a rectangle here is equal to 1/3. And then the area of the unshaded goes from 1 to 2 of the function dx. Okay, and so that is x cubed over 3 minus x from 1 to 2, which is 8 over 3 minus 2 minus 1 over 3 minus 1. Okay, so this would be 6 over 3, so 2 over 3, and this is minus 2 over 3, so this would be 4 over 3, okay? And so that's the area of the 2, we'll call it area 2. And so then area 1 would simply be this 3 minus this area 2. So the whole rectangle minus the non-shaded. Okay, so that's 9 over 3 minus 4 over 3, so 5 over 3. Another way to do this problem would be to take the shaded area and just push it down. So if I took this shaded area and just imagined it being pushed down, okay, so push, 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 then this leading point went down 3 units. This tip point went down 3 units, just a vertical shift, so I could minus 3 here. Okay, so just imagine a push. And then this is going to be y equals x squared minus 4. So you could do the integral from 1 to 2 of x squared minus 4 dx. All right, but we got to remember that we moved it, so we want to, this is going to give you a negative area, so we want to make sure we address that when we give our final answer, because the original shaded region is going to be a positive answer. So x cubed over 3 minus 4x from 1 to 2, 8 over 3 minus 8 minus 1 over 3 minus 4. Okay, so if I put this over 3, this is going to be negative 16 over 3. And here, this is going to be minus, make that a 12, minus, made a mistake somewhere here, so let me pause. No, I haven't. I don't know. I'm fine. I don't know what I was thinking there. So this is negative 12 over 3, which is negative 11 over 3. All is good. And so this is negative 16 over 3 plus 11 over 3, which is negative 5 over 3. Okay? And so you would just need to make sure you give your final answer back as, therefore, positive 5 over 3, because we shifted it, and that's not part of the original problem. All right. So that is page 1. I think I'll stop there. I'm going to pause that. I've got to go run up to the office, and I'll come back and pick up on page 2. All right, page 2 here, 6.4, part 2. All right, so sketch the graph of f of x equals x squared minus 4x plus 3 for the interval negative 1 to 4. Shade the regions between the curve and the x-axis. Label them as R1, R2, and R3. All right, so we have a parabola. So let's do our left bound. Let's just do negative 1. So negative 1 will be 1, right? So negative 1 squared will be 1, and then plus 4, because negative 1 there, plus 4, and then 3, that's 8. Okay, so it'll be all the way negative 1 up to 8, 2, 4, 6, 8. Okay, let's go ahead and look at 4, 16 minus 16, and then 3. So at 4 will be at 3. Looks like we have a y-intercept at 3, so there also. So vertex will be between those two since they're on the same. Vertex will be at 2. So you could use the quadratic, you could use the piece of the quadratic formula that finds the vertex, negative b over 2a. That would shake out to be 2. You could use calculus and take the derivative of 2x minus 4, set it to 0. That would also equal 2. Or you can just see these are on level. So this has to be somewhere at 2. So let's plug 2 in there and we get 4. All right, so we get 4 minus 8, so negative, so we'll be at negative 1. All right, so that shows us that we're going to have some area above and some area below for this situation. Okay, so down we go, up we go, and down we go. So this, we are R1, R2, and this is R3. All right. Okay, so let's find this integral. To pretend we're on a non-calc part, so x cubed over 3 minus 2x squared plus 3x from negative 1 to 4. So let's plug in 4 and then minus off negative 1. Okay, so 64 over 3 minus 32 plus 12, 64 over 3 minus 20, so minus 60 over 3. All right, over here that's negative 1 over 3 minus 2, and then minus 3. All right, so it's negative 5 and 1/3. Let's make sure I did that right. Yep, okay, so negative 5 and 1/3. All right, so this is 4 over 3 minus a minus, so plus. That's 15/16 over 3. Just go from a mixed number to an improper fraction. All this math from years gone by coming in 20 over 3. Okay, and that's just going to be here, and that's going to be unit squared. I'm just having it represent a two-dimensional area, so unit squared. Again, we'll transition to something different in a bit, but for now, U squared is fine. All right, the total area then is going to be a little different So total area, I'm going to need to, so this is the net. Total area, I'm going to need to pop this up as positive area. So really just put the absolute value there. But I'm going to have to split the integral. So when you do total area, if you're not on calculator, it's a bit of a pain because you have to split the integral. So I need to go from -1 to 1, and I'm just going to write f of x dx. I'm going to illustrate the concept here, and I'm going to add in the absolute value of this number, right? So I'm going to do from 1 to 3, f of x dx. And whatever I compute here, I know it's going to be negative. I'm going to absolute value that. Plus 3 to 4, and this is positive. Okay, so I already know this is x cubed over 3 minus 2x squared plus 3x from -1 to 1 plus same antiderivative, just different bounds. Let's put a big old absolute value symbol on that. All right, so 1 over 3 minus 2 plus 3 minus -1 over 3 minus 2 minus 3. Okay, so that's this first area here. This is 1 1/3, so 4/3, minus, this will be minus, plus, that's going to be our, again, -5 1/3, okay, as right here, we got 16 over 3. Okay, so it looks like this first area then is 20 over 3. And we're going to be adding these, so let's just bring this up, 20 over 3. All right, let's do this next area in absolute value. Okay, so I'm plugging in 3, so 20 sets 9 minus, that's going to be 18, and then plus 9. Ooh, 0 there. And then minus 1. We've already assessed 1 over here, which was 4 over 3. Okay, so this is just going to be 0, 4 over 3. And that's an absolute value. Actually, it was negative. Let's do this correctly. It was negative 4 over 3. In absolute value, so that'll be plus 4 over 3. See if I got it all. Yep, that's just 0, negative 4 over 3, and absolute value. Okay? And then our last one, plus 64 over 3. Okay, 60 minus 32 plus 12. And then this 3 we already did right here. That's just going to be 0. All right, so I'm looking at that's negative 20. So we already kind of did negative 20. Okay, and so that's going to be 4 over 3. All right, so total area, 28 over 3 units squared. Kind of interesting that this first piece was also that, right? That was also, so these two pieces must, were the same. Interesting. All right, next one. Did I do everything there? All right, let's move on. Okay, if x squared minus 4x plus 3 is the velocity function, what do these all represent? Well, R1, region 1, is distance traveled in the positive direction from t equal to -1 to 1. Okay, well that's a little weird. t equal to -1. I don't know. This isn't really appropriate to that function, in my opinion. We should have started the interval at 0 if we're going to ask about velocity. But maybe we're time traveling. I don't know. All right, so R2 here is going to be the distance traveled in the negative direction. From t equal 1, 2, 3. And then R3 is the distance traveled in the positive direction from t equal 3 to 4. Okay, so what does the 20 over 3 is total? See, now this is where it wouldn't be units squared, right? That doesn't make any sense. So this would just be 20 over 3 units. So that's a little bit weird, right? Because we were u squared when we're talking about space, but now we're just 20 over 3 units in the positive direction. Okay? From the starting point. And that's the concept of displacement. Total area then is a 28 over 3 units is the total distance traveled. Okay, if you were to go on your TI and just do the whole thing in one swoop, you would go from -1 to 4 and put absolute values on that function. Because if you absolute value the positive pieces, that's all fine. So let's do that here. We'll just go, already kind of done. That lets me, we got x squared minus 4x plus 3 comma x comma -1 comma 4. Thinking. Okay, and 28 over 3. Boom, there you go. Little different back here, but that's okay. That's why AP exam just rounds us to 3. All right, so steps. Finding the total area analytically. So this means without the TI. You want to factor to find the zeros because that's where you'll be able to have a split from positive to negative area. Partition AB with the zeros and integrate over each subinterval and add, I guess that should be capital, add the absolute value of the integrals. Values are there. All right, about a 23-minute video, so I think I'm going to leave this at page 2 and start a new one starting on page 3. Break it up. All right, sounds good. See you guys later.